Question 6. The function f is defined by f of x is equal to 3 minus 2x over x minus 5. X is an element of real numbers and x is not equal to 5. We're asked to find the inverse function of x. So to find the inverse function is really straightforward. We know that f of x is equal to y. So what we do is we rearrange this function so that we get x equals. So let's try and do that. So we're going to get y x minus 5y by cross multiplying is equal to 3 minus 2x. Now we want to get x equals instead of y equals. So if we bring the 2x across, we have yx plus 2x is equal to 3 plus 5y. X times y plus 2 is equal to 3 plus 5y. And then we divide across by y plus 2 to get x is equal to 3 plus 5y over y plus 2. And then we change our y, so we say the inverse of x is equal to 3 plus 5x over, you replace the y with x at the end, x plus 2. Now we can check this. So let's put a value into our original function. Here's my original function. Let's try f of 1 and see what we get. F of 1 is equal to 3 minus 2 over 1 minus 5, which is equal to 1 over minus 4, or minus 1 over 4. So the point 1 minus 1 over 4 is in the original function. Now let's see what happens if we put this value, minus 1 over 4, into the inverse function. So we're going to get the inverse function. Let's put minus 1 over 4 in. See what we get. We're going to get 3 plus 5 times minus 1 over 4 over minus 1 over 4 plus 2. And if we change them into quarters, we have 12 quarters minus 5 quarters on top. And we have 8 quarters minus 1 quarter on the bottom, which is 7 quarters, which is going to be 7 over 4 divided by 7 over 4, which is equal to 1. So the point minus 1 over 4, 1 is on the inverse function. Now, can we see a relationship between these? This is the knowledge required in inverse functions. For the inverse function, the points in the original function just swap places. So you can see the x, the 1, has become my y, and my y has become my x. And this will help us in the next part, or the final part of this question. The next part of this question, you're told the function g has a domain minus 1 less than x less than 8 and is linear from minus 1, 9 to 2, 0. Let's go a little bit heavier on it. This part of the graph here is linear from here to here, and again from here to here. So 2-part linear. So that's the point 2, 0, minus 1, minus 9, and this is 4, 8. Write down the range of g. Well, the range is the domain. You can see here, the domain is the x, the range are the y values. So the range goes from minus 9 to 4. Minus 9 to 4 is the range for my function. Part C asks you to find f of g of 8, so a function inside a function. Now g of 8, here's 8. G of 8 gives me an answer of 4, so we're actually looking for f of 4. So we need to go back up to my function f, which was appearing here somewhere, this guy here. So I just put f of 4 in here. F of 4 is equal to 3 minus 2 by 4 over 4 minus 5, which is equal to 3 minus 6 over minus 1, which is equal to minus 3 over minus 1, which is equal to 3. Just go back there. 3 minus 8 over minus 1, so we're going to get minus 5 over minus 1, which is equal to 5. So that's part B. And then the last part, our knowledge of inverse functions is important. We're asked to sketch the graph of y is equal to, sketch the graph of y is equal to the inverse of g. So all we need from, as I said earlier, we need these points. So if we look at this bottom half of the graph here, the red bit at the bottom, or all of it, but it was actually cutting the axis at 0, minus 6. So the inverse of that is going to be minus 6, 0. We also have the point minus 1, minus 9. And the reverse of that is minus 9, minus 1. And we also have this point here, 2, 0. which is going to go to 0, 2. And these are all, an inverse graph is reflected in the line y is equal to x. So let's see if we can sketch that. So we have the point 0, minus 6, approximately. It's minus 6, 0 is approximately here. Minus 9, minus 1. I'm going to just need to make the graph a little bit bigger. So we need to identify the points. Minus 6, 0. Minus 9, minus 1. Approximately here. And the other point was 0, 2, which is approximately here. If we draw this line, I'll do it in a different color. It's going to look like this. So does that look like it's reflected in the line y is equal to x? Or that these distances the same distances across? They're fairly close. Fairly close. Okay, the second line, this one here. What points have we got? We've got the point 2, 0 and 8, 4. So the inverse of those is going to be 0, 2 and 4, 8. So change color. So 0, 2 and 4, 8. So it'll be up a bit. So 2, 4 approximately there, and 8 is approximately up here. 4, 8. So the purple line looks like it's the inverse of, I'll change this into purple, of this one, and you can see it does look like it's reflected through the y-axis. So these are pretty accurate. You guys are going to have used graph paper and been a little bit more accurate than me.